In this screencast, we introduce the idea of a function, and we discuss different ways that functions can be represented. A function is an input-output process in which each numerical input is assigned at most one numerical output. Shown below is what is called a flow diagram, and we can use flow diagrams to illustrate how a function works. A function is a process, and it takes numbers, which are the inputs, and it turns them into other numerical outputs. The special feature of a function is each time you put a number in, you get at most one number coming out. A helpful analogy to think of when you're working with functions is that of a vending machine. A function is like a vending machine, so imagine this box here is a vending machine. A vending machine is a process of turning money into food, and a function is a process of turning one number into another number. With a vending machine, the input is the money you put in, and the output is the food you get out. Each time you put in money, you get at most one item of food coming out. Generally, you get one item coming out, but if you don't put in enough money, you may not get any food coming out. A function behaves exactly the same way. There are several ways to represent functions. One way is flow diagrams, but there are other ways, and we introduce these representations with the following example. Example 4.1. Consider the following process. Take any given number and then square it. Then subtract 5. This process can be represented or described in 4 different ways. We can draw the function using a picture diagram. That's the flow diagram you saw above. That's one way of representing this function. Another way of representing this function is by an equation or an algebraic representation. A third way of representing a function is by using a table of values, and a fourth approach is by using a graph. In this screencast, we will talk about the first 3. In the next screencast, we'll talk about graphing functions. So let's start by talking about picture representations or flow diagrams. So let's make a flow diagram. That's this picture above. Let's make one of these flow diagrams for the process in this example. Okay, so the thing to start off with is making a box to contain the process. So in this process we have our inputs and we have our output. Okay, what does this process do to numbers? Well, the first thing that this process does is it squares a number. So that's step 1 in the process. So I take my input and I square it. That's the first thing that happens. Then what? After squaring, we subtract 5. After we've done that, we get our output. So this is a flow diagram or a picture representation of this function. A second way that we can represent a function is through an input-output table. Shown here is an input-output table for the process we just looked at. So in the first column, I have 4 different inputs, 4 different numbers that we could put into the function. And in the second column, we have the outputs, which we can fill in. So if we put the number 4 into this function, what happens to 4? It gets squared. 4 squared is 16. 16 take away 5 is 11. So if we put 4 into this function, we get 11 coming out. Now let's take -3 and put it into the function. The first thing that will happen to -3 is it gets squared. -3 squared is 9. Then you subtract 5. 9 minus 5 is 4, so the output is 4. Now let's put 0 into the function. If I square 0, I get 0, and then I subtract 5, and I get an output of -5. Finally, if we put the number 3 into this function, it gets squared, and we get 9. Then we subtract 5, and we're back at 4. So again, the second column represents the outputs from these 4 numerical inputs. So based on your work here, can you see that this process is a function? So let's go back and just review what a function is. The key feature of a function is every time you put in a number, you get at most one number coming out. Well, is that how this process works? Every time we put in a number, did we get at most one number coming out? We did. It's not possible to put a number into this process and get 2 or more outputs. So this process is a function. In the table above, you inserted values into the function and you obtained output values. Whenever you do this, this is called evaluation. So evaluation is the process of taking a number, putting it into a function, and calculating the output. So for example, suppose you were asked to evaluate this function at 2. What does that mean? What it means is you're being asked to take the number 2, put it into the function, and figure out the output. Well, let's think about it. If you took 2 and you squared it, you would get 4. If you subtract 5 from the 4, you get a -1. So the output is -1. We would say the function evaluates to -1. So this is the numerical representation of a function. Now let's talk about representing functions algebraically. That means by using an equation. When working with functions, there will always be at least 2 variables. There will be 1 or more input variables. These are called independent variables. And there will be exactly 1 output variable, which is called the dependent variable. So let me draw a picture to help you see what I'm talking about here. So this is a flow diagram, and the function is the process in the middle, and then we have our input and our output. So when we say a function has at least 2 variables, let's think about that. The number you put in can change. It's variable. So the input represents one of the variables. The number you get out varies also depending on what you put in. So the output is another variable. The output depends on what you put in. So the output is called the dependent variable, and the input is the independent variable. For the function we're talking about in this example, an algebraic representation would be an equation that relates the output to the input. Let's look at this equation. Does it describe the process in this example? Well, let's start by looking at the right-hand side. This says take the input and square it, then subtract 5. Is that what the process does? It is. If I take my input and I square it and I subtract 5, I get the output. This equation conveys what the function does. We generally use letters to represent the input and output variables instead of actually writing the words input and output. So for example, The equation on the previous page, where it said output is equal to input squared minus 5, it could be written, for example, this way, or this way, or this way. Let's compare them. In this case, we're saying a letter B is squared, we're subtracting 5, and the result is the variable s. Since we're squaring b and subtracting 5 from the result, b is playing the role of the input. The answer, our output, is represented by s. So b is the input variable, s is the output variable, or b is the independent variable and s is the dependent variable. Let's look at the next one. T squared minus 5. So t is playing the role of the input because we're squaring it and subtracting 5. U is playing the role of the output, or the dependent variable. In the last equation, x is playing the role of the independent variable, or input, and y is playing the role of the dependent variable, or the output. All of these equations convey exactly the same meaning. The only difference is the choice of letter names. In your mathematical career, you may encounter the phrase, y is a function of x. So let's talk about what that means. The phrase means that the letters x and y represent the input and output variables, respectively, of a certain function. In other words, x represents the input of a function and y represents the output of a function. Another way of translating this phrase is to say y depends on x. So when you hear the phrase y is a function of x, think to yourself, y depends on x. So in our current example, if we look at the equation involving the variables b and s, would we say b is a function of s, or would we say s is a function of b? Well, let's translate these. B is a function of s. That means b depends on s. In other words, b must be the output and s is the input. This phrase, when translated, says s depends on b, which means b is the input and s is the output. If we look at our equation above, b is the input and s is the output. So s depends on b. So s is a function of b. That's the correct phrase to use in this case. In the next screencast, we will talk about the fourth way of representing a function, namely graphs.